Okay, now turn your attention to the problem on the right-hand side of the board here. How do we tell if it's going to work? Well, here's the process. You always write down what by what, and it's R by C. RC is right, like remote control. Okay, here we go. So I want to change this to what by what, right here. That is a what? 1 by 2. And this one is a 3 by 2. And therefore, it's not going to work because those don't match up. Yeah, but you can't. It's a good question. I know what you mean. You were thinking, and there are situations where you can rearrange them and then they would work, but you can't. You got to just... Okay, so moving on. Oh, okay. You're right. I was in the other one and I hadn't finished it. Okay, back to this problem. I need to figure out these three numbers, right? Okay, well, that little map tells me how to do it. Row 1, column 1. It tells me right in there that I want row 1 and column 1. Well, row 1, I'm going to go up to my Neato pens here. Here's row 1. Here's column 1. And the 1 goes with the 10, and 0 goes with the -8, and the 2 goes with the 4. Do you get how those go together? Okay, so 1 times 10, this is a times problem, right? 1 times 10, 0 times -8, and 2 times 4. Well, 1 times 10 is 10, plus the 0 times 8 makes 0, plus the 2 times 4 makes 8. 10 plus the 0 plus the 8 makes 18. See how I got that? All right, so that's 18 in here. Let's do the next one, and I can just kind of go like this. It's kind of cool. I just move this down, and then it's row 2, column 1. That's going to be -10, -32, which makes -42 total, and then +20. +20 and -42, -22. -22. And then the last one is, move this down one more notch. 0, -8, +12. -8 and +12 make what? 4. There we go. Those are my three numbers. I got it kind of messy. I want to do one more of those. Okay, here's a simple one. See if you can do it. 2, 3, 4, -1. And that is a 2 by 2 matrix, right? So if I want to make this work, what does my other matrix have to start with? 2 by something. And could it be 2 by 2? Yeah. As long as it's 2 by anything. Okay, I'm going to make it 2 by 1 just to make my life simpler and yours too. This will be 0 and 1 and 2. Okay, go ahead and multiply those together. Oopie. Okay, let's go with 0 and 1. Sorry. All right. Multiply it together, see what you get. Okay, so my first thought is, what is it? It's a 2 by 1 matrix for an answer. So that means it looks like this with 2 spots for answers. And this one's row 1, column 1. This is row 2, column 1. Once I got my map made, it's easy to go find the buried treasure. So I take this and I go row 1, column 1. 0, 3, 0 plus 3 makes 3. So this is 3. Raise your hand if you agree with me on that. Good. And the other one, J, back row. Tell me what to do. 4, we'll move this down. 4 times 0. Okay, 4 times 0 is 0, and -1 times 1. -1 plus the 0. -1. Okay, raise your hand if you had the same thing as him. All right, excellent. So there's your basics on multiplying matrices. Then let's look at the next topic, which is linear programming. I'm going to fly through this really quick. When you do linear programming, you're basically writing inequalities, like there's more than 10 people in line. So you say, let's say x is the number of people in line, so you'd say x is greater than 10. All right? You're going to graph things like that, except you don't graph them this old way where you only have one variable. We graph them where you have 2 variables. Actually, this is just one variable again, but with 2 constraints. But we get into the kind that have 2 variables. So typically you have an x and a y like this. You got to solve it for y, and to solve it for y, it looks kind of like this. Is that solved for y yet? No, because I got to get rid of the negative. And how do I get rid of the negative? Multiply by a negative. And what happens when you multiply by negative? You flip the sign. So final answer is the sign is flipped, and there it is. And I'd graph that. And when I graph that, I get this line first, and then I got a shade. So I'm changing it to what it was, which was greater than, so I shade where? Above it, like that. And then I make another one, and that's a line going straight up and down. It's right here. And then which way am I going to shade on that one? It says y is greater than or equal or less than or equal to 6. Yep. So if I shade to the left, it'll look like that. And when I put the two together, I end up with the feasible region, which is that yellow area. That's the overlapped area. Okay? And now, if I go farther with this and graph one more thing in there, that dotted line, notice it doesn't have a line here, so it's a dotted line. All right? And then it says less than, so I shade underneath it. And that looks like that. I put it all together, and the feasible regions where they all overlap. And then the important parts are the corners. Those are called something special which starts with a V. Do you remember what it is? The vertices. All right, so those vertices then get plugged into my problem, and I figure out where I get the max profit. Do you really think, if this is a profit problem, that I would have ever have that situation? No, because that's something that's negative. Could you make negative units of, like, I made negative DVD players today. You can't do that. That's like unmaking DVD players. Okay, so in this situation, I'd say that must be the max profit. Okay, but usually there's what's called real world constraints, which would be like right here, a line that means got to stay on this side of 0. And there's another one that's like this, got to stay on that side of 0. All right, that's a basic review of this kind of a problem. I don't want to take forever on those. Applications unit. This is a typical D equals RT problem. D equals RT. Make me one of these charts right now. You're going to want to do this with me to remember how this works. All right, so if we have the boy and his dad, and I just keep on looking through and trying to find info and plugging it in. The boy went 20 miles an hour, so I put rate 20. And then he landed 1.2 hours later. That's a time, 1.2. And then his dad left on the bike 24 minutes later, and it'd be really easy to just think you write 24, but you got to change minutes into hours, and so 24 out of 64, when you actually divide that, you get, 60. 24 out of 60 ends up being 0.4. That's the reason I had the 4 in my head. So that the difference between these two is 0.4. So most of you guys know that you should put the 0.4 in here somehow, but it also is related to the 1.2. Just answer me this. Who was in the situation longer, the boy or his dad? The boy is, so this time should be bigger than this time should be. So I should take the 1.2 and take away the 0.4, because you just have to reason it through and say, well, this must be smaller, so I'm going to make it smaller by subtracting them. Then I don't know the rate that dad went. That's the point. So I put an R here. And I don't know the distance that they went, but I can say that the distances are the same, so I call them both D. Remember that? Then I've got a system of equations. D equals 20 times 1.2. And the other equation right here is D equals R times 1.2 minus 0.8. Let's just say that's 0.8. And now I can do substitution. Wherever I see a D, I can put an R times 0.8, so I'd put that here, and then I would solve for R, and we'd all be happy and live happily ever after. Okay, moving along. We get to, this is just a summary of how to answer that question. The last general big topic is weighted grades. I want you to think for a second of what your grade is right now in this class. Whatever it says on Skyward lately, that's probably what your grade is. You'll need a percentage. You can't just go A. You got to be, or A minus. You got to guess your percent. Okay, and here's how you set up weighted grades. If you have a 0.85 weight on this part, which is the 2 quarters put together, and then a 0.15 on the final, which is correct, and then I add them together, and then I want a total of a grade of, I'm going to make this situation. I know most of you guys want a straight A, so we're going to go with 92.5 is what you want. But actually you go 0.925 because we keep these all in decimals. Okay, then let's say Joe Blow had a 0.90 going into this, and he doesn't know what he's going to get on the final, but he wants to know what he needs to average an A. That's how you do it. The only number you got to change is this one to make it real for yourself. Go ahead and change that for yourself to a number and solve it. And once you solve this one down, you get the kid has to get 106% on the final, which means it's impossible for this kid to get a straight A average. He had an A minus, the lowest A minus going, So you just can't get up to a straight A with just the final. And on the other hand, some kids can get like a D on their final and still pass, but that'll be in your transcript, and you don't want that on your transcript.